All right. Hi, everybody. So today we're going to be talking about 10.3, which is experimental and theoretical probability. So to start, make sure you have your math composition notebook and you are taking these notes in your notebook. And first thing you should write is the learning target, which is I will be able to find the experimental and theoretical probability of an event. So make sure you have that down in your notebook and then you can press play and we'll keep going. So, first thing we're going to talk about is experimental probability. So, experimental probability is based on repeated trials of an experiment. Okay, it's based on repeated trials of an experiment. So, I do need you to write this down, please. The probability of an event, in the case that it's experimental probability, is the number of times the event occurs in the numerator over the total number of trials. Okay, so you're going to need this formula down so that you can use it in the examples on the homework. Okay, once you have it down, let's move on. Okay, so finding an experimental probability. The bar graph shows the results of rolling a number cube 50 times. 50 times. What is the experimental probability of rolling an odd number? Rolling an odd number. Okay, so first let's write down the equation since it's experimental probability. So the probability of the event is the number of times the event occurs over the total number of trials. So number of times the event occurs. So the first thing we want to note over here is that odd numbers are 1, 3, and 5. So now we need to read the graph, okay? Because it's asking me what are the odds of rolling an odd number. So if we look on the y-axis, times rolled is here and the number rolled here. So we want to look at 1, 3, and 5. So I see that the 1 is rolled 10 times, the 3 is rolled 8 times, and the 5 is rolled, looks like 11 times. So what I'm going to do is I'm going to add all these up, okay? Because if I add these up, that's going to tell me how many times the event of rolling an odd number occurs. So I'm going to go 10 plus 8 plus 11, and that's going to give me 29, okay? So I'm going to put that up in the numerator where it says number of times the event occurs because, again, we were looking for how many times is an odd number rolled. So we looked at each of the odd numbers and added up how many they were rolled. So 29 is the number that represents how many times an odd number was rolled. And then the bottom, the denominator, is going to be the total number of trials. And that says it up here that they rolled it 50 times. So you could count all of them over in the chart, or you could just read that this says 50 times right here. So 50 times because it's out of total of 50 rolls. Okay, so now the experimental probability is 29 over 50. If I want to get the percentage of it in your calculator, what you're going to do is you're going to go 29 divided by 50. That should give you this decimal, 0.58. And then if you want to turn this into a percent, you just move it to the right, and that'll give you 58%. So the experimental probability is 29 over 50, 58%, or 0.58. For this one. Okay, make sure you have this down. Then we're going to go to the next one. Okay, so the next idea of this section is going to be theoretical probability. So theoretical probability is when all possible outcomes are equally likely. The theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. So again, the number of favorable outcomes. This is a little bit different language because favorable outcomes is, well, how many times could it happen? And then the possible outcomes is, well, how many times possible out of how many times could it happen? So make sure you write this down in your notebook, the probability of an event. And again, this is theoretical probability. Make sure you label that. So write this down because you're going to need this for our assignment. Once you have this down, let's move on to our example 2. Okay, so finding a theoretical probability. It says you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? Okay, so let's think about it. So first, let's write down our probability of an event for theoretical probability. So that's just this formula right here that I had you write down. So let's rewrite it. It's number of favorable outcomes on the top over number of possible outcomes on the bottom. Okay, so the probability of a vowel. So that's what it wants us to find is what is the theoretical probability of choosing a vowel? So first we need to know what a vowel is. Well, I know that E is a vowel. I know that O is a vowel. Then again, E is a vowel. So I know that there are 3 favorable outcomes, and that is because there are 3 vowels. Okay, and our 3 vowels are E, O, and E. Over how many possible outcomes are there? Well, we just need to count up how many letters there are. So there's 1, 2, 3, 4, 5, 6, 7. So I'm going to write 7 in the denominator because there's a total of 7 letters. So the theoretical probability of choosing a vowel is 3 over 7. Or in your calculator, remember, you can do 3 divided by 7, and that's going to give you the decimal of 0.43. Move it to the right 2 times, and you're going to get 43%. So the theoretical probability of choosing a vowel is 43%, 3 over 7, or 0.43. Okay, so that is how you are going to be finding the experimental probability and the theoretical probability. Make sure you have both of these setups, and you are going to practice it with the Big Ideas homework when you go to do that today. So, awesome job. Thanks for watching.